So, what is reinforcement learning, you may ask? I'm going to use this diagram here to try to explain to you the difference between reinforcement learning and the other forms of machine learning that you might be aware of. You probably may have heard of supervised learning, unsupervised learning, and reinforcement learning. Now, reinforcement learning is the closest we can come, or as at yet, the closest we have gotten to in terms of mimicking how human beings actually learn. And the reason I am saying this is, if you have any experience in machine learning, you realize that to teach a computer to be able to know that this is a duster and this is a pen, you realize you have to show it thousands or tens of thousands or even hundreds of thousands of different pictures of both of these items in different orientations, different backgrounds, different lighting conditions and all that, before the neural network will hopefully be able to distinguish between this item and this item. But I'm also sure you will agree with me that it doesn't take tens of examples to show a baby what this is. Like, if you show this thing to a baby maybe 5 times that this is a pen, the baby will begin to learn patterns that forms an association with any object that he or she will identify as a pen. You don't have to show the baby hundreds of examples. What happens is the baby learns through correction. So if you show a baby that this is a pen, it is very likely that next time when the baby sees this, he might say pen. And what happens is you, the parent, will be there to correct the baby and say, no, this is not a pen. This is a glue gun, but this is a pen. And you can even take another example of a pen and show it to the baby and say, this is a pen. So the difference between reinforcement learning and supervised learning is that for supervised learning, you need to do a lot of data capturing and labeling, which can be very expensive if you don't have open data sets for the problem that you want to solve. The beauty about reinforcement learning is that the agent that is performing the task captures data on its own through interaction with its environment. Okay, so like the baby scenario that I gave you, the baby, by telling the mother that this is a pen, is actually indirectly capturing new data, because by saying this is a pen, the mother goes to say, no, this is not a pen, this is a pen, and this is also a pen. And so the learning task is on the baby to figure out why these two are pens and this is not a pen. So the learning is dependent on the baby being able to form associations between the physical form of the object that he is seeing to the final target label that will be assigned to it. Okay, so the beauty about reinforcement learning is it is cheap in some sense, in the sense that you don't have to sit and gather data, tens of thousands of data, label them before you build a model. What happens is you train a model, you build a model, you build the agent, and then you place the agent in an environment. So if it is a self-driving car, you build the self-driving car, and the agent here is a code that controls what the car does. Okay, I said it in the previous session that sometimes people confuse, especially in robotics, people will confuse the robot to be the agent. It is not entirely wrong, because the agent, which is the source code, controls what the robot does. So you are not entirely wrong, but technically the agent is the brain, the piece of code that runs on the computer that is controlling the robot. So like I was saying, if it is a self-driving car example, what happens is you build a self-driving car, you write a code, you place it on the computer in the car, and then you put the car in the environment and it has to drive around. Now, how will the car know that it doesn't have to run into human beings. It doesn't have to run into other cars. It doesn't have to knock human beings. It doesn't have to cross when there's traffic light and stuff like that. It comes by interacting with the environment. Let me give you one other example to help you. If a baby, I'm using babies because, like I said, it is the closest we have gotten when it comes to mimicking how human beings learn. So if a baby sees fire for the first time, the baby has no idea that this thing could be hurtful if I don't play with it carefully. Of course, fire is not something that you can play with, but fire can give you warmth. So if you are too cold, you go close enough to the fire to get warm. But you go any closer and it burns you. Probably can even kill you. So how will a baby learn to associate the right distance to be away from a source of fire to get warm but not burnt? What happens is, maybe for the start, if you don't like the baby example, let me use a dog. Maybe for the start, the dog can get too close to the fire and even get burnt. And it will register in its mind that getting too close to this fire gives me a negative feeling. That is the reward. I will explain this diagram, but I'm giving you all these scenarios so that this diagram is easy for you to understand. So anything that is painful will be interpreted as a negative reward. And anything that is good, that gives good feeling, will be interpreted as a positive reward. Okay, so these are few scenarios that I want to give you so that you will be able to understand how reinforcement learning works and how it is different from normal supervised learning and unsupervised learning. Okay, so this diagram here is going to help me to explain to you the workflow in reinforcement learning.